Okay, here on example 2, we're going to find all of the real solutions, not just the ones on the interval from 0 to 2 pi. And so what happens here is that each time we rotate or revolve around the unit circle, we will get more answers. And so each time we get to an answer, if we just add a revolution all the way around the circle, that will be another solution, and so on and so forth. And we can rotate in the positive direction or in the negative direction. And so to symbolize that, to put that into mathematical symbols, what we're going to do is basically find the solutions from 0 to 2 pi, just like we did in example 1, and then we're going to add rotations to them. And the way we're going to symbolize that is just by adding 2 pi k to our answers, where k is any integer. And so that's going to be a way to symbolize any solution to these equations, where basically you can plug in any integer for k, and that's going to give you a solution to the equation. But it first of all starts with finding the solutions from 0 to 2 pi, which is what we practice in example 1. And so if we look here at example A, here on example 2, 2 sine squared x minus 1 is equal to 0. And so what we're going to do here is isolate our sine squared of x by first of all adding 1 to the other side and then dividing by 2. And so this will give sine squared x is equal to 1/2. Now this is where you want to be very careful. We want to get sine x by itself. And so therefore the next step would be to take the square root of both sides, and I'm going to do that in a different color here. Square root of the sine squared of x is sine of x, but actually, really, to be honest with you, it's actually absolute value of sine of x is equal to 1 over the square root of 2. And so therefore, what that means is that sine of x is going to equal to both positive and negative 1 divided by the square root of 2. And I really want to emphasize the fact that square root of sine squared x is absolute value of sine x, because otherwise you're going to miss this plus or minus, and therefore you're going to be missing half of your answers. And I don't want you to be missing half of your answers. I want you to get all of the solutions to this equation. And so don't forget the plus or minus whenever you take the square root. And so what you really see here is that this is plus or minus square root of 2 over 2. Because 1 over the square root of 2, when you rationalize, is really just square root of 2 over 2. And so that's a value on my unit circle. It corresponds to the angle. Theta is equal to pi divided by 4. That's the reference angle that we're going to need. Now, which quadrants are we going to need? Well, sine of x is going to be positive in quadrants 1 and in quadrants 2, and it's going to be negative in quadrant 3 and quadrant 4. And we need all 4 of those, again, because of the plus or minus. And so in each of these 4 quadrants, we're going to put pi over 4 as our reference angle. And remember, that reference angle is between the x-axis and the angle, so that's why I'm drawing it back to the x-axis. And so in quadrant 1, that's obviously pretty straightforward. It's just pi over 4. In quadrant 2, remember this is pi. We're going to be going backwards from pi 1/4 of a pi, and so that's going to be 3/4 of a pi, or 3 pi over 4. In quadrant 3, we're going to be going forward pi over 4, so now adding pi over 4 to pi, and so that's going to be 5 pi over 4. And then in quadrant 4, we're going to be going backwards from 2 pi, which is really the same thing as 8 pi over 4. And so if I go backwards 1 over 4, that's going to be 7 pi over 4. And so I've got 4 answers to this equation right there. But remember, and I boxed this maybe a little bit early, so I'm going to unbox it here. Remember that I want to find all of the real solutions. And so what I'm going to do to find all of the real solutions is just write out a statement here for all 4 of these. Pi over 4 plus 2 pi times k. and x is equal to 3 pi over 4 plus 2 pi k, any integer number of revolutions. X is equal to 5 pi over 4 plus 2 pi times k, where k is any integer. And then finally, x is equal to 7 pi over 4 plus 2 pi k. And so all four of these statements are the final answer. They represent all of the real solutions to this equation. Okay, here on letter B, I again see that I have a double angle expression here, cosine of 2x, and so I want to get that out of the equation if possible. And so remember, for cosine of 2x, we have three options in order to be able to get rid of that. We want to use the one that makes sense in the context of the given equation. And so notice that letter B here, this equation has cosine x written all over it. And so therefore, I want to use the identity for cosine of 2x that has cosine x only in it. And so what that's going to look like is the following. We're going to just write down the left-hand side, 2 cosine squared x plus cosine x, and then cosine 2x is going to be 2 cosine squared x minus 1. Now, this is convenient because what I realize is that 2 cosine squared x is on both sides of the equation. So what we could do is just subtract it on both sides and it will cancel out. Therefore, we'll just be left with cosine x is equal to -1. And so where is cosine x equal to -1? Well, that's got to be on a quadrantal angle. -1, the x value is going to be over here. The point is -1, 0, but the angle, which is really what we want, is pi. And so this is going to be x is equal to pi plus, because I want all of the solutions, 2 pi k. Now, I am perfectly fine if you box that and report it as your final answer, but I'm going to go a little step further here just to show you something that I think is interesting and cool. If I factor out a pi from our answer, then what we're left with is 1 plus 2k. And remember that k is any integer. And so let's just talk about this for a second. What happens when I take any integer and I double it? Well, it becomes even. If it was even already, then doubling it makes it continue to be even. And if it was odd and I double it, then it becomes even. And then when I add 1 to something that's even, what does that do to the entire number? Well, it becomes odd. And so the answer, the solution to this equation, would be represented by all odd multiples of pi. And so that's just a verbal way of describing all of the solutions. But like I said, pi plus 2 pi k will be just fine for us, or you could go a step further and write it like that. Either way would be perfectly fine. But I did want to show you that the solutions to this equation are represented by all of the odd multiples of pi. Okay, the last equation here is again in quadratic form, and so this is going to be very similar to solving the equation 4x squared minus 4x plus 1 is equal to 0, except obviously instead of x, we have sine x in its place. And so because the lead coefficient is not a 1, I need to multiply the ends here. And so the multiply number is 4, and the add number would be -4. And so that's going to be -2 and -2. Those are the two numbers that multiply to +4 and yet add to -4. And so I'm going to take this equation and write down its ends, and then in the middle have two sine x terms that both have the coefficient of -2. And so there's my setup for my factoring. I'm going to group together these first two terms and take out what they have in common, which is a 2 sine x, and that's going to leave me with a 2 sine x minus 1. And then from the second two terms, the only thing I can really take out is a -1, and that will again leave me with 2 sine x minus 1. And so therefore I'm going to have the same factor twice here, 2 sine x minus 1 and 2 sine x minus 1 is equal to 0. And so setting those equal to 0. In both cases, we're going to get sine of x is equal to 1/2. And remember, that is a value on my chart. I know that sine being 1/2 corresponds to the angle pi over 6. And so I just need to figure out what quadrants sine is going to be positive 1/2. And that's going to be in quadrant 1 and in quadrant 2, again, because of our acronym. And so we want the reference angle in quadrant 1 and 2 to be pi over 6. And so the first set of solutions is going to be pi over 6 plus 2 pi k. And the second set of solutions, remember, we're going to subtract backwards from pi, and so that's going to be 5 pi over 6 plus 2 pi k. And so that's going to do it for solving trigonometric equations. If you guys have any questions about that, please do not hesitate to reach out, and I hope you guys have a good day.